In this video, we're going to talk about solving rational equations. So a rational equation is just an equation that has any rational expression. So you'll see a variable in a denominator. Let's first start talking about domain. The domain is the set of all values that the variable can assume in an expression. So what we can think about is thinking about the numbers that would make the rational expression undefined and just exclude those from all real numbers. So for example, if we have the expression 5 minus x over x plus 1, the value that would make this expression undefined would be the value that makes the denominator 0. In this case, -1 would make that denominator 0. So x could assume any value, any real number, except for -1 because it makes the denominator 0. And for rational expressions, that's what we need to worry about. So my method of solving rational equations always involves thinking about the domain first so that you know which values would be no good for your variable. So again, your definition, a rational equation is any equation that involves a rational expression. So again, you'll see a variable in a denominator. So the method we're going to use here to solve would be to clear out denominators, solve whatever kind of equation you have, and then check your answers, and meaning check your answers with the domain, not just check to make sure that you've solved correctly. All right, so we're going to take a look at several examples. Let's start with the first one that you see here, which I already have right now. All right, so we see this as a rational expression because there are variables in the denominator. We're going to first check the domain. I'm going to write that off to the side. The domain is any values that make any of the expressions undefined. So look at each denominator that has a variable and set it equal to 0 to see what value that would give you. So p equals 0 is one value that makes this undefined. So 0 would make that undefined. If 4p is equal to 0, if I solve this for p, I'm still going to get p equals 0. So your domain is all reals, I'm just going to write this in words, all reals except p equals 0. So any value that we get for p should be okay except for p equals 0. There are lots of different ways to write the domain, but for us we're just kind of writing this as a little note for ourselves that we can get any solution except p equals 0 is no good. All right, so our next step is to begin to solve. So the strategy that we're going to use is to clear out the denominators by looking for the least common denominator. So here my LCD would contain all of the different factors, all the different common multiples. So I have 4 and 8. The common multiple would be 8. And I just have p to the first power, so I don't need to worry about thinking about the powers. My least common multiple will be 8p. So I'm multiplying every single term by 8p, or both sides of the equation by the same value. And again, p is not equal to 0, so it's okay that I'm doing this. All right, when I multiply 8p times every single term, the denominators will cancel. So for this example, I'll show the step and then do the cancellation in the second step, but you can begin to do this mentally as well. So I have 8p times 8, which is 64p over p, plus 8p times 1 is 8p over 4p, equals 8p times 11 is 88p over 8. So again, if you could simplify as you're writing that down, that's fine. It'll save you a little bit of writing, but if not, simplify it here. The p's are going to cancel. The p's cancel here. 4 goes into 8 2 times. 8 goes into 88 11 times. So my equation is now 64 plus 2 equals 11p. Think about what kind of equation this is. I have p to the first power. That means it's a linear equation. So I want to isolate p. 64 plus 2 is 66 equals 11p. isolate p again, divide by 11 on both sides, and I have 6 equals p. All right, so when you're checking, you should check this with the domain, make sure it agrees with the domain. We said we're allowed to get any value except for 0. This is not 0, so that's good. So that means that algebraically, as long as you went through the process of solving correctly, you should have a solution that makes sense. You could always go back and take your solution and plug it in, make sure the left side equals the right side, and that it agrees that way. That works as well. So here our solution set, I'll just write it in roster form, is just the one value, 6. Let's take a look at the second example that I already have written out down below. Here we have a different style of rational equation. This style is called a proportion. We know that because we only have one rational expression on each side. So because you have this type of equation, you can solve this in a slightly different way, which still also involves finding the least common denominator, but it kind of eliminates that step of simplifying. And this is the process of cross multiplying. Again, this only works because I have one rational expression on one side, one rational expression on the other side. So in order for them to be equal, the cross products have to be equal. So I'm going to multiply the cross products together. But these are polynomials, so I have to be careful when I'm multiplying. So I'm multiplying 2x plus 1 times 2x plus 3, and that should be equal to 4 times x minus 1 times x plus 3. You know what? Before I forget, let's find the domain, because now that we have eliminated denominators, we don't want to forget where this came from. All right, so let's go back and look at the domain before we continue here. So the domain would be all reals except for the values that make these two denominators 0. So the first denominator, x plus 3, is 0 when x is equal to -3. So -3 is out. The second denominator here, 2x plus 3 equals 0. That means that 2x would be equal to -3, and x would be equal to -3 halves. So my domain is all reals except these two. So all reals except -3 and -3 halves. So these are the values that we want to be aware of. If we get -3 as the solution or -3 halves as a solution, then we know that value is no good and we'll throw it out. All right, let's continue. So we need to multiply in order to figure out what type of equation we have. So here, multiplying the binomials, I have 4x squared. The outside will be 6x, the inside is 2x, so that's 8x. And then the last is 3. Right, on the other side, I'm going to multiply the binomials first, then I'll distribute the 4. X times x is x squared. The inside is -1x. The outside is positive 3x, so that's positive 2x, and then minus 3. Let me distribute that 4. 4x squared plus 8x minus 12. Oh, and I see here 4x squared plus 8x plus 12. All right, so let's see what happens here. I want to try to get the variables on the same side, but I'm seeing that no matter what I do, it looks like the x's are going to cancel out. So if let's say subtract 4x from both sides, that cancels out the x squared term here and here. If I subtract 8x from both sides, those cancel out as well. So I'm left with 12 equals -12, which is false. So that means that my equation has no solutions because the variable cancels out entirely, but the statement that I'm left with is false. So our solution set is the empty set.